Alice, Bob, and Eve explain Pauli operators.
You know, Bob, is it not interesting how I can describe any point on Earth using just latitude and longitude coordinates on this globe here?
That reminds me of Pauli operators in quantum computing. They're like the coordinate system of the quantum world.
Pauli operators are such fundamental building blocks in quantum computing. They're named after Wolfgang Pauli and come as a set of 3 special matrices, X, Y, and Z.
How do these operators relate to my globe?
Think of your globe as representing a single qubit, a quantum bit. Just like you need coordinates to describe locations on your globe, we need Pauli operators to completely describe and manipulate the state of a qubit.
The Pauli Z operator is like the north-south axis of your globe. It distinguishes between the 0 state at the North Pole and the 1 state at the South Pole.
What about points along the equator?
That's where the Pauli X and Y operators come in. The X operator flips states between 0 and 1. It's like rotating your globe 180 degrees around the equator, swapping north and south poles.
The Pauli Y operator is similar to X, but it adds a phase change, a quantum property with no classical analog. If X rotates around the X-axis, Y rotates around the Y-axis.
So these operators are like different ways of rotating my globe?
Exactly. Together, they allow us to rotate a qubit's state to any point on what we call the Bloch sphere, the quantum equivalent of your globe.
There's also the identity operator, I, which does nothing, like holding your globe still.
And in quantum computing, these operators are everywhere. Quantum gates, the basic operations in quantum circuits, are often based on Pauli operators. The X gate is a quantum NOT gate, flipping between 0 and 1.
They're also crucial for quantum measurements. When we measure a qubit, we're essentially measuring along one of these Pauli axes.
And I'm guessing they have mathematical properties that make them useful?
Yes, they form a mathematical basis. Any operation on a single qubit can be expressed as a combination of Pauli operators. They also have special commutation relationships that are fundamental to quantum mechanics.
2 Pauli operators either commute, meaning the order doesn't matter, or anti-commute, meaning the order changes the sign of the result.
So just as I can locate any point on Earth using the right coordinates, these Pauli operators let you navigate and manipulate the state of a qubit?
Perfect analogy. And just as maps and globes helped explorers navigate our world, Pauli operators help quantum physicists and engineers navigate the quantum realm. They're the compass, map, and stars of quantum navigation, essential tools for anyone working with quantum systems.